Okay, sir. This is the third video to explain the base case and the load flow program. We start to clear and CLC, and after that, the initial parameters, the charging power level 2s, 7 kilowatt, and the number of AV, total number of AV in the system. And after that, we call also or load the system database, as we explained before, and the network bus data, the network line data, and also the AV charging models. And after that, to preparing data. How to preparing data? It is dependent on the, as you see here, it is dependent on the AV model for each type. As you see here, for each type we have a profile, as explained in the charging model, and how much it should be arrived, and how much hour needed to return back to full charge, and as you mentioned, the total number. This is the power charging of AV during 24 hours. Each hour we will calculate how much power from the whole our system, and for the whole type. And as you see here, if you run this now and open it, we have 10 profile, and this is the type 1, type 2 to 10, and how much the power in each hours. How much the power in each hours. It is dependent, as you explained before, dependent on the arriving time, and dependent on the distance that take it in the trip, and how much the power consumed in our trip, and need how much power also needed for to recharge the battery of the AV to full. And after that, after we calculated the power charging of AV for all the type or whole type of PV, and now we will sum it to calculate the AV power total load, and also to this is to calculate it also the load profile of the system. And after that, from sum it between the load profile of the system and the AV profile, now we calculated the peak load, the maximum peak load. And after that, now calculating the cost charging, it is dependent also each type. As you see here, this is for the whole type, and this is the system the charging price from the database, as you see here, multiply by each type of a profile, a power profile, and then as you see here, now you can see it, the cost of each type. This is the total cost. This is the total cost for the type 1. This is the total cost, charging cost, total charging cost for type 2, and for type 3, and for type of 14. It is also dependent on the when the type is charging, and also the capacity or the quantity of energy that will that type it charged. And after we finished from the calculated of the cost, now we go to the load flows program, and we will explain later. And the load flow to calculate it, as you see here, the power loss, and as you see here, the power loss, the reactive power loss, the voltage profile for the system, and the power loss during the each hours. How to calculate that, and after that we printed the result, the power loss. Now we will go to printed the result and explain the result. The power loss, as you see here, it is the 5,248, and the reactive power loss 30,522, and the peak load, as you see here, 5009, and also the minimum voltage at 0.9127, and total charging cost. This is the total charging cost of all the system, as you see here, and the type charging cost. Each type, how much the cost from each type. And this is the printed result, and we have a graph also, the load flow, the load profile, sorry, the system load, how to behave. This is as you see here, the behave, and this is the peak load, as you see here, and the charging peak near the peaking. Also, this is maybe rise the peak load, as you see here, and as you see here, during the day there is no any charging, because the AV, it is leave the home. This is the two thing, the system load and profile, and AV load profile behave during the day for 24 hours. And the second graph, it is the voltage profile of the system. This is the average load profile. This is average for all the 24 hours. This is average, as you see here. We have in each buses we have some values of the in per unit of the AV, and as you see here, at bus 18 we have the minimum voltage in 0.9126, the minimum voltage, and as you see here at bus 33 also we have also another minimum, but more than the 18 bus, but also it is minimum, as you see here. And this is lower value of the voltage at that two buses. And the last graph about the power, the AV types of a profile, how each type behave during the 24 hours. As you see here, type this is the type maybe 3, as you see here, how to behave charging this, and after that finished during the day, and after that we return back, as you see here. And also the same thing about this type of the generation, as you see here, or maybe type 5, this is the green one, and how to behave during the days. And this is for the base case and the result. And the last one, it is how the load flow. As you see here, we have input and output. The output, it is the power loss, the accumulated power loss, and this is accumulated reactive power loss for 24 hours, and this is the average load voltage profile. And the last one, it is the power loss, accumulated power loss for all buses, but during the hours. As you see here, we first initial parameters, and we call the load data bus and the line data bus, and after that preparing some data for put it some this to be zeros, and determine how many branches and how many buses, and after that base MVA, base kilovolt, and the base impedance. And after that we calculated the per unit of the system resistance and reactance in the per unit dependent on the base impedance. And after that we started the loop for 24 hours. We will make load flow for 24 hours. What is the change in each load flow? It is this, the power and reactive power. The power and power and reactive power dependent on two things. The real power first, dependent on the profile that contained in the system data, and also the dependent on the power from the AV on each buses. So now here we determine two things: the how much the PV in each buses, and put it in the load of that buses, and the profile also multiply by the profile. So the real power, it is the nominal power, real power of the each of the bus, multiply by the profile of the system, plus the how much power from the AV. How to calculate it? That it is dependent on the how much the percentage from the total of the AV. This is the number of AV at each bus divided by the total number of AV multiplied by the PV power charging AV profile for each type, and after that we sum it this from the whole type. What does that mean? That mean in each bus we have the 10 different profile of each buses, so dependent on the number of AVs. And after that we divided by the base MVAs, and the reactive power, it is dependent on only the nominal reactive power of the system multiplied by profile of the system data bus and divided by the base. So this is the main thing that we change in each hours, the power and reactive power. And after that we make load flow to calculate the losses dependent on the real power and reactive power that we calculated on each hour. But very important command here. This is the very important command. It is the nominal power, real power of the system multiply the system rolled profile plus the sum of from the whole type of AV multiplied by the number of AV at that bus divided by the total number of AV in the systems. This is the important equation that we calculated here. And after that, now we arranged this from this to this from line 33 to line 150 until this 154 voltage current program. This is to arrange that buses to make load flow and to calculate voltage current program. Yeah, this is command to arrange only, to make some paths, somehow to power flow from from the source to the load, and how much path in the program or in the network, and how to connect it between each the buses. This is to arrange and prepare the buses and network to make the voltage current program. And after we preparation that, now we started to calculate the current voltage program. And the first thing, it is to assumed in all the number of all the bus we have that they have one voltage per unit. This is assuming. First thing, it is assumed that all voltage at each buses it is 1 per unit. And after that we started with the loop. This is loop to calculate it. The first thing, it is dependent on the real power and reactive power in that hour divided by the voltage bus that we assumed in the first step by 1 to calculate the net current in each from each buses. And after we calculated the net current from for each buses, now we started to calculate the branch current. The branch current, that means the current flow from bus some bus, from bus maybe 1 to bus 2, from bus A to bus B. This is the branch current, and dependent on the net current in each calculation. And after that, as you see here, we accumulated, maybe we have accumulated of each line for each line we have accumulated branch current. Why accumulated? Because the current that we flow from 1 to 2 contain different current, because the current contain the current flow from 1 to 2, and the current contain from 2 to 3, and current contain dependent on the path. That we means accumulated branch current. So we calculated the current that flow from 1 to 2, but not only for that the bus 2 to cover bus 2 load, but also for cover all the bus that in that path between the current one, bus 1 and bus 2, and so on. This is to calculate the accumulated branch current. And after we accumulated or calculated the branch current, now feed back forward to calculate the bus, as you see here. From what we get it from the branching calculated current and from the resistance and reactance, and we calculated the new voltage of each bus dependent on the first process of calculated of the branch current. And this is repeated, this process 4 times, as you see here, to now get the voltage at each buses and the voltage angle and also the branch current. And after that we get the branch current and the voltage at each buses. Now it is load flow finished. Now start to calculate the power loss and reactive power loss, as you see here, and accumulated that. And also, as you see here, we calculated the voltage, and this process will repeated, and this is accumulated, as you see here now. And this is for the power loss of each hours. So after we finish this process, now we finished the 1 hours, and this process will repeated in each hour for 24 hours and accumulated in this 2 or 3 variables. And after that, this is mean that we calculated the accumulated power loss of for 24 hours. We calculated the power loss at each hours and the accumulated reactive power of each hours, and then also calculated the voltage, accumulated voltage of each hours. And after we finished this process for 24 hours, now we calculate, because to the meaningful of the voltage, you need to calculate the average of that profile and the average of voltage for our systems. And after we finished that, we output, as we mentioned and explained before, that real power, reactive power, and power loss at each hours, and printed in our results, and back to and printed also figures for voltage and other things. That's it, the code explanation for the base case. We hope it is clear for you, and if you have any questions or some misunderstanding in some points or some lines, we are happy to listen from you, and if you have any suggestions or any other maybe assumptions, or any other adding variables, or adding parameters, or any other things do you want to add it in the program before we start to optimization process and the program, we are able to do that before that. And if you it is okay, you can reply to us to be okay, and to go to the next step of the optimization case to calculate the demand response effect of the AV on the system and on the charging consumer, and on the power loss also, and all of other things. Thank you very much, and we wait your response. Goodbye.